Year 11, this first video is going to be on the first two exercises of Chapter 9, Probability. Most of this you've already done. We did this in Year 10. So I don't really need to do a lot, and if you're okay with it, go straight to the exercises and give it a go. But there are some things you need to know. Now, first of all, if you look at the chapters there, chapters 1, 2, 3, 4, 5, 6 are all things that we have done before. The only chapter or the only exercise that is going to be new is conditional probability, and I've already done a video on that, or a YouTube clip on that, and that's pretty difficult. Hopefully we'll be able to go over it more in class. So let's have a look. You probably already know most of these, but it's good to go over them and check them again, knowing all those different things and what they mean. We're going to have a look at a few today, particularly set notation. So let's have a look at what they talk about. Now, sample space, that's just when you have an event. And when we talk about an event, we talk about the probability of an event. And I'm not going to write it all out, but the probability of an event, we write it like that. Now, when we have an event, the sample space is everything that can happen. So the sample space, say, of rolling a dice, I'm just going to make sure I get the right. So the sample space of rolling a dice, well, all the things that can happen are 1, 2, 3, 4, 5, and 6. A die, sorry, when you roll a single die. The sample space of tossing a coin, a head or a tail. Now, even though some things occur more often, it doesn't change the sample space. So, for example, for tossing 2 coins, the sample space for tossing 2 coins, well, you can get 2 heads, a head and a tail, and I'm going to count that as one thing. It doesn't matter the order. I'm not concerned about the order. Or 2 tails. Oh, geez, 2 tails. Now, we know that that can happen in 2 out of 4 ways, because when we toss 2 coins, fundamental counting principle, 2 times 2 means that there are going to be 4 things that can happen. And if I was just counting the number of heads and tails, that is only 1 in the sample space, but it is twice as likely. So this is 2 in 4, this is 1 in 4, and this is 1 in 4. But the sample space remains the same. Let's make it a bit easier. Let's have another one. If I roll 2 dice and I add the 2 faces, well, the lowest number I can get is 2 ones, and they're added together, they give me a 2. And then I have a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, 11, and a 12. Now, to get a 12, the only way I can get a 12 is to get a 6 and a 6. It has a 1 in 36 chance. There are 36 things, different things that can happen. But as you can see, I haven't got 36 things in my sample space because some of them have a higher probability. For example, to get a 7, there are lots of ways I can get a 7. I can get a 1 and a 6. I can get a 2 and a 5. I can get a 3 and a 4. And I can get them all in the reverse order. So there are 6 out of 36 ways that can happen. So remember, the sample space is just a list of everything that can happen. So that's pretty easy. You don't have to list things twice. Now, make sure you've got this in your notes. The probability of an event is the total number of events or favourable events over the total number of outcomes. Now, this is what you've got to understand. Union and intersection. Union means everything. Intersection just means the things that are in both sets of 2, and they can be independent, 2 things. So, the Venn diagram covers it completely. As you can see there, union is everything in set A and B. Intersection, the upside down U, is just the things that are in both. So there's a good example here. So they've just got, I don't know, a hat full of different numbers. So 1, 2, 3, 4, 5, 8 in hat A, and 3, 6, 8, 9, 10 in hat B. Well, if I've got the numbers from 1 to 10, and you can see here, there's a 2. Well, it's not in either hat. That's not in hat A or hat B. I have 2 numbers in both hats, a 3 and an A. I have these numbers in hat B plus these numbers, all in hat B, and I have these numbers in hat A plus these numbers. And the union are the 3 and the 8. Everything in A and B is 1, 3, 4, 5, 6, 7, 8, 9, 10. There's no 7 there either. Oh, there's a 7. 1, 2, 3, 4. Why'd they put it up there? 3, 4, 5, 6. 1, 3, 4, 5, 6, 8, 9, 10. So understanding notation is important. So let's have a look at these, make sure. Okay, so I'm not going to do all of these. Tossing a coin we've already done. The sample space of a radio station 1 to 5. 1, 2, 3, 4, 5. Wrong brackets. Rolling an 8-sided die with different numbers 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm not going to waste any time on there, too easy. Intersection and union. Okay, so I'm just going to do the first one. So the sample space, find the pair of sets where X is the intersection with Y. Well, I'm just looking for things that are in X that are in Y. So I think there's a 4 in both and there's a 2 in both. So my intersection sample space is 2 and 4. My union is everything that's in both sets. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? And I'm not going to do the other one, but if I'm looking for things that are in both, there's a white in there and there's a white in there and a red and a red. So the union is red and white, and the intersection is red and white, and the union is red, white, and yellow. Righto. If I move along, let's get 1. The probability that no. So have a look at these. You can think about these. If we're having to have a race, and Usain Bolt happens to be in our 100-meter running race, and there's 8 of us in the race. Let's say it's 8 of you from the class. Not all of you have the same chance of winning. Usain Bolt is an Olympic champion. He has a much higher chance of winning. The same as with the horses in the Melbourne Cup. Not all horses, not every horse has the same probability of winning. The same as in if we were to swim in a swimming race against Ariane Titmus, we would be in a bit of trouble because Ariane Titmus has a higher probability of winning than us. So that's pretty obvious. Masters golf is the same. A coin came up 8 tails 8 times in a row, so the next one must be head. Yes, you must be very careful about this. This is called the law of averages. It's not true. It doesn't happen. The coin does not have a memory. The coin does not remember. You could toss that coin 8 times and it'd come up tails 8 times, put it in your pocket or put it away in a box. 20 years later, you pull that coin out. The coin doesn't remember. So there's no such thing. Every time you toss the coin, the probability of a head or tail is still 1 on 2, 50%, 0.5, whatever you want. The probability, right, the same thing for the D. The probability of Decatur winning motor P is 6 on 47 because there are 6. No, and we've already talked about that. Okay, Simone must roll an even number on a die. Write the sample space rolling. What is the set of even number? Oh my goodness me. Should we even bother with this? Write down the sample space rolling a die. Okay, so we've done that. 1, 2, 3, 4, 5, 6. And the sample space, what is the set of even numbers? 2, 4, 6. Right. Okay. Venn diagram. All right, what do we got? So Venn diagram, we've got two intersecting circles. And we've got K, and we've got L. I'm just using the letters. K's got Monday, Thursday, Friday. And the other one's got Tuesday, Thursday, Saturday. So Thursday's in the middle. I'm going to do, I better do a TH for Thursday because I've got a Tuesday in there. So K also has Friday and Monday. So Monday and Friday. And event L has Tuesday and Saturday. So Tuesday and Saturday. And I'm just double checking. I'm pretty sure I'm right. Oh, come on, where is it? Yep, righto. So you can do all those. They're pretty easy. Now, relative frequency. Not all things are straight. So we use statistics. So you'll notice that when most of you would have your L's. And if you ask Mum and Dad, did my insurance premiums go up for driving? Did our insurance premiums go up for driving the car? And they'll say, yes, we had to pay more money to insure the car now that you are a driver. And you think to yourself, well, why is that? That is because the companies that provide the insurance have collected data and worked out the probability of an accident occurring when there is a younger driver in the car, a learner driver, or even, I think it's 16 to 25. If you have a driver in your car or someone who's driving your car regularly who's 16 to 25, you must pay a higher insurance premium because they've collected the statistics on all the number of crashes that have occurred and worked out the probability that with a younger driver, you're more likely to have an accident. So how do we do this at a very basic level? So relative frequency. What we do with relative frequency, we just create another column. And I'm going to do it here for this one. And I'm just going to call it RF, the relative frequency. So what I do here is I've got these scores on a maths test. Must be, I assume it's out of 10, could be out of anything. And they're the number of kids who got it. So what you first need is you need to add up this column. What do we got? 6 and 4 is 10. 7, 1 and 2 is 10. I'm getting 23. I'm getting 23 for those. Now, the relative frequency is just this number over that number. So 6 on, I'm going to make this bigger because I can hardly write. 6 on 23, 4 on 23. I'm just going to rub that out and make it a bit neater. So 6 on 23, 4 on 23, 1 on 23. I do them all in a line, but it's not very big. 2 on 23. Oops. And 3 on 23. Now, when I add this frequency column up, the total must always equal 1. 23 on 23. All those numbers must add up to 23 on 23 because you can't have a probability greater than 1. Right. So the relative frequency is pretty easy. Now, if I look at some of the questions, if a student scored at random from this, if you choose a student at random, there are 23 kids in the class, if the principal comes in and says, student M, I want you, what's the chance that they scored 8? Well, it's 2 on 23 because there are 2 children in the class who scored 8. There are 23 children in the class. What's the probability that a student passed if a pass mark is 5? Well, you add up all these ones. All right. Hold on. Pass mark is 5. No, you add up all these ones because 5's a pass and 4. And this is really cool, you can just go, well, 6 failed, or 6 didn't pass. So therefore, the number who passed is 1 minus 6 on 23. But you'll all be thinking 23 minus 6 on 23, because that's what 1 is, 23 on 23. So 17 on 23 passed. And that is what we call, and it's a very useful law, the complementary law. So the probability of an event, and you can write it 2 ways, is 1 minus the probability of not the event. And we indicate not with the dash above the E. And because this is an equation, we can write it the other way. The probability of not an event is 1 minus the probability of the event. So, for example, if I said to you, there's a 30% chance of rain, what's the chance of it not raining? And straight away, you go 70%. But what you don't realise, in your head, you've gone 100% minus 30%, and 100% is 1, gives me 70%. So you've actually used this law, the complementary law. All right, I'm going to move on from a couple of these because I think we're doing the even ones. So I'm going to jump down here to question 4. Table shows science. Are there many more? 6, 8. Okay, so I'll go down and I'll do a stem and leaf. So 4. Science experiments to find the velocity of an object when it's rolled down a ramp. If I'm doing the problem, I have to create a relative frequency and make it bigger so I can fit it all in. So I add up all the numbers. So 2 and 7, and this 1 gives me 10, and 10, there are 20. So the frequency column, and that Greek symbol, sigma, just means add up the frequency column. So all my answers are going to be over 20. Now, 2 over 20, this is my relative frequency column. 7 over 20, 4 over 20, 1 over 20, and 6 over 20. Now, in the answers, they simplify those, but I prefer to leave them as over 20 for the meanwhile, because I know that it's got to add up to a total over 20, and I might have to add things together, and I want a common denominator. Find the probability that an object selected at random rolls down the ramp with a velocity between 5 and 7. Oh, okay. This is how you write it. Probability 5 to 7 equals 7 on 20, because there are 7 of them. Oh, 11 and 13, 1 on 20. 11 to 13, 1 on 20. 11 to 16. Okay, all of a sudden, 11 to 16, we're taking these two. So the probability of 11 to 16 is 1 on 20 plus 6 on 20, 7 on 20. I'm not going to do any more of those because you can have a look at them, and I'm looking at the work solutions and they're pretty easy. The last one I'm going to do is one of these ones where you actually have to make it into a frequency distribution table first. So I'm not going to do that one because you can do that. Oh, where's it gone? What the hell has happened? Oh, there, it's come back. Goodness me. Wish it wouldn't do that. Okay, so, don't do it again. Right, so you can make up a frequency distribution table for that. I'm going to do it for number 7. So number 7, what are my x's? Dot plot, we don't even know what this is. It's a score. Remember, the symbol for a score is an X. And we've got 4, 5, 6, 7, 8, and 9. I'll put my frequency in. And we've got 1, 4, 1, 2, 3, 4, 5 5s. That's not nice. 3 6s, 1, 2, 3, 4, 6 7s, 2 8s, and 3 9s. So my relative frequency, I've got to add them up. Excuse me. 1 and 5 is 6, plus another 6 is 12, plus 2 is 15, plus another 5 is 20. I'm making it nice and easy for us. So my relative frequencies are 1 over 20, 5 over 20. I know I can simplify that, but I would prefer, if I'm going to be answering questions on probability, to keep it as 5 over 20, 6 over 20, 2 over 20, and 3 over 20. Okay. So, from the dot plot, find the probability of an outcome chosen at random, score of 8. Well, there it is. Go away. Score of 8 is 2 on 20. What question am I doing? 7. I'm looking at the wrong answers. I've got a really worrying thing then. Now, they've written these as a decimal. And they like them as a, so you could write these as a decimal. If you went along and did all these, you could get a decimal answer. So 1 on 20, 0.05. 5 on 20 is a quarter, 0.25. 3 on 20, 0.15. All I'm doing is halving these, because if they're out of 10, 3 on 20, 0.3. 2 over 20, 0.1. 3 on 20, 0.15. You just halve the number on top. Puts it over 10, makes it a nice easy decimal. So 0.5, there's my decimals. What's the probability of an 8? So the probability of an 8, and whatever this thing is, we don't know what it is, 0.1. What's the probability of at least a 6? At least a 6. Well, I can get 6, assuming that this is a mark or something. I've got to get the 6, the 8, the 7, the 8, and the 9. So of at least a 6, the probability of at least getting 6. So that means you want 6 or more. So that means you want all of these. So I'm going to do them as a fraction first. I prefer working with fractions. 3 and 6 is 9, plus 5 is 14. So 14 on 20, and that is a decimal, half the top, 0.7. I'm right, it's a decimal. At least a 6. You could have added up the decimals. I'm going to stop there because this is pretty much very easy, and you can have a go at these yourself. That is relative frequency, plus we've added in something that's coming up in the next exercise, which was a complementary rule up here. Remember to use appropriate terminology. You don't have to write a lot, but at least show as much working as you can. Good luck.